A very good afternoon and a warm welcome to the 2025 edition of the Autocar Professional Vehicle Lightweighting Conference, brought to you by Sika and powered by Pioneer. This two-day virtual seminar is our humble attempt at diving deep into the important subject of lightweighting, which has become paramount in today's time to drive efficiency in both ICE and electric vehicles. Over the course of the next 2 days of this virtual seminar, we will have a series of top industry executives sharing their insights around lightweighting and its allied topics, such as the use of lighter materials, modern design innovations, advanced manufacturing techniques, and how this engineering methodology is driving the industry towards offering more sustainable and cleaner mobility. Good afternoon once again. My name is Mayank Dhingra, and I would like to thank you all for joining us today. And without any further ado, let's open the event. And to kick off the proceedings with a keynote address, I would like to invite a very special guest, someone who needs no introduction in the automotive fraternity, an engineer par excellence, and the man behind developing some of Maruti Suzuki's best-selling models, Mr. C.V. Raman, member of the executive committee and former CTO, Maruti Suzuki India. Mr. Raman is a distinguished industry leader with over 3 decades of experience at the company, and he has played a pivotal role in shaping Maruti Suzuki's product strategy. He has spearheaded the development of numerous iconic models like the Swift, Zen, and Brezza, tailored to the Indian market. Known for his deep technical expertise, he has been instrumental in localizing global technologies and driving innovation in areas such as vehicle design, safety, emissions, and fuel efficiency. A mechanical engineer by training, Mr. Raman's leadership approach continues to contribute significantly to the growth and transformation of the entire Indian automotive industry. Raman-san, it's an honor to have you inaugurate the Vehicle Lightweighting Conference with your keynote address, and I'm sure the audience has been waiting with bated breath to learn the nuances of this subject from an industry stalwart like you. Over to you, Raman-san.
So, good afternoon, everybody, and thank you all, and thank you, Mayank-san, for the very nice introduction. And thank you and to Ketan-san and to Horma-san for inviting me for this lightweighting conference. It's a topic which is very important. It's something which we live on every day, and as engineers, that's very, very important. So I will put some context and some pictures to the words. And so I will just share a presentation and then we will go from there. So, yeah, so is my presentation visible?
Yes.
Yeah. So thank you. I wanted to talk about lightweighting, but before I talk a little bit in detail, talk a little bit about the auto industry as such. And we all know this, all the auto professionals around who are there on this call. We are, the largest manufacturer of three-wheelers and tractors. We are the second largest manufacturer of two-wheelers. We are the fourth largest manufacturer of passenger cars, and we are, having a very good contribution towards the GDP. 50% of the manufacturing GDP almost is coming from the auto industry. And, as we go towards, our objective as Amrit Kal 2047, we want to be the third largest economy. I feel, and it's important that mobility is going to take center stage in the manufacturing sector and drive this growth in a big way. And we are going to be, if we are going to be a $30 trillion economy in the next 20 years, the auto industry is going to contribute a very significant portion of this. And towards that, the growth has been very, very significant. And if you see, it's, continuously growing in terms of two-wheelers, passenger cars, commercial vehicles, and so on and so forth. And today, if we are a $2.53 trillion economy, the auto industry itself and the mobility industry is going to contribute that much to the GDP in 2047. So it's important that we grow this industry in a sustainable way, and the pillars of sustainability from an India context is that we need to minimize the environment impact when we are doing this growth. We need to keep in mind the society, health, safety, equality, and progress. And of course, the economics. We have to have sustained value creation, which will propel this overall ecosystem. But having said that, today's context also is something which we should keep in mind. Our national objectives are for energy security, we want to reduce the oil import bill. 87% of the crude is imported. We are the fourth largest greenhouse gas emitter, with mobility contributing 13%. We would, like to, improve that, reduce that. And of course, we have, from a local pollution perspective, we are eighth in the world in the most polluted countries. And so therefore, it's important that we work towards that. So future regulations are focusing on some of these aspects from emissions, safety, as well as from a connected, perspective. Phase-wise CAFE norms. First two phases are already there, set 2017 and 2022. Next phase is under discussion. We have already implemented BS6. Phase 2, we are going to go to WLTP in 2027. A lot of focus on biofuels, electrification. From safety, we already have the BNCAP, which has been notified, and we are working on ADAS related technologies going forward. And as vehicles are getting more connected phase-wise, cyber security norms are also under discussion. Now coming specifically to passenger cars, you can see that the growth is going to be there. In 2030, we should be almost 6 million, and by 2040, we could be about 10 million vehicles. Growing this market in a very sustainable way is going to be key. But one thing which is there is that the customer is also changing as we are, and we are making products for the customer. Customer is always looking at the exterior, the interior, and also looking at the aerodynamics of the vehicles. And in a way, we all want to have make sure that the customer is satisfied through appealing products. And that's what brings the customer into the showroom. But having said that, next step is that the performance has to be good, and he also looks at the comfort, convenience, and of course fuel efficiency also is important. And coupled with that, the industry is also working towards various new technologies. From a sustainability perspective, from the requirement perspective, in terms of electric mobility, in terms of advanced human-machine interface, as well as autonomous vehicles or level 2 ADAS and so on. All of this is increasing the features in the vehicle, and the weight is something which always comes with anything which you add to the product. So I think that's one of the key challenges which today all engineers face. And there are technology disruptions which are happening. We all talk about autonomous, connected, electrified technologies, but today technology disruptions are also happening from across the other realms in the ecosystem. And we need to be cognizant of that and make sure that the auto industry is abreast of that. And we are going through a major transformation, and that is good. We are going to see that in the next 5 to 10 years. the key question is how do we, drive this growth in a very, very sustainable way? So we'll talk a little bit about, some of the, technologies and some of the things which, we in Maruti Suzuki are doing, or we as auto industry are doing. So, we will be continuously upgrading the, ICE powertrains, because, that's something which is, contributing in a way to the fuel efficiency improvements. And we also need to look at alternate fuels through CNG and alternate fuel, ethanol, and flex fuel vehicles. We need to look at hybridization, and hybridization is one of the key technologies going forward, and electrification, and in future fuel cells. These are, technologies which are the powertrain is going to continuously evolve, and these environment friendly and energy secure technologies are going to be key for the mobility going forward. But when we are looking at all these technologies, what I would like to bring to focus is that if you add CNG, there is a 8% improvement, increase in weight over the ICE vehicle. If you strong hybrid, the weight goes up further, and if you have an electric vehicle, the weight goes even much further, almost 1.5 times. So this is the things which we need to look at. And technology introduction means that weight is going to go up, and when weight goes up, there is always the impact towards fuel efficiency. And we have seen that any reduction in weight improves fuel efficiency and also improves the CO2 per kilometer. And so that's something is the significance of lightweighting in the auto industry. And it's a compulsion. It's something which every engineer strives for, to reduce weight in every aggregate and every system which they are working, designing, and manufacturing. So I will just introduce Suzuki's global philosophy, which is Shosho Ketan B, which means smaller, fewer, lighter, shorter, and neater. It's a way of life. It's in the way in which we do our work. It's a way to design and manufacture our products, and this is required to be done by all stakeholders, not just by Maruti and Suzuki, but by all our stakeholders. That's what we are emphasizing, and that's the DNA of Suzuki global philosophy, which we are continuing to work on. Every engineer is given a target of weight when he is designing a part or a system, and it's to the extent it could be 1 gram per part, or to that extent, weight reduction is so important for engineers in Maruti Suzuki. Some of the key initiatives which we have is changing over from sheet metal parts to plastic parts. Say, for example, a fuel box, we are changing out from sheet metal to a plastic. Fuel tank changed from metal to plastic. The casting parts being changed into plastic, or cast iron becoming aluminum. So these are various types of initiatives which every engineer is looking at in developing newer parts, and that all contributes towards the weight reduction of vehicles. So let me just explain this through an example. And if you see, the Maruti Suzuki Swift was first launched in 2005. And over the last 20 years, we have seen 4 generations of the Swift. When we launched the Swift in 2005, the weight was 980 kg, and the fuel efficiency was 12.36 kilometers, and it was a G13 1.3 liter engine. But over the years, you can see there has been increased use of high tensile steel. We have used things like plastic fuel tank. We have changed the platform to the hard tech 5th generation. platform, increased use of high tensile steel. And the third generation, the weight was 855 kg. It was meeting BS6 norm. So as the emission norms and regulations have become stringent, the customers' requirements and aspirations have changed. The content and the equipment has increased. However, the weight is something which we always have been looking at, and we have reduced that weight. And in the Swift 4 generation, today we have the weight is 900 kg, and we are meeting BS6 phase 2. The fuel efficiency has improved. We have introduced a new engine. We have improved the NVH, and all of this, and we have introduced 6 airbags in this model. So all of this has contributed to weight increase, but from a sustainability quotient perspective, you can see the CO2 has come down in terms of the fuel efficiency improvement which has happened. So I think that is something which is what we say is it's in practice the Shosho Ketanvi which we talk about, smaller, lighter, fewer meter, is exemplified through this example of Swift over the last four generations. Having said that, if you go to some generic technologies which manufacturers are looking at, every manufacturer today is looking at alternate materials. We are looking at ultra high tensile steel continuously, and especially when we are looking at electrification, hybridization, and battery electric vehicles. As the weight goes up, every kilowatt hour of the battery contributes significantly to the weight. And if you want a higher battery capacity, 20 kilowatt, 30 kilowatt, 40 kilowatt, the weight goes up, in the same ratio. And so therefore, it's imperative that we reduce the weight, use high tensile steel, or use alternate materials like aluminum or thermoplastics. And in some cases, some of the manufacturers also looking at magnesium, and magnesium alloys in a big way. So these are some of the lightweighting trends. And it's not just, one system which one has to look at lightweighting. It's all the systems, whether it is powertrain, whether it is structural, whether it is acoustics and insulation. Every area we have to, work on. Say in CNG, or if you go in future towards hydrogen, blended CNG, we'll have to move towards a composite cylinder. That will reduce the weight also, but of course there is a cost impact. Similarly, composite materials in the structural areas, and looking at acoustics and insulation and other interior parts. We have to look at how to easily mold, identify, dismantle, such parts, and that I'll talk a little bit about that later. And we have to make sure that high strength to weight ratio is something which we all work towards. Improve the strength and reduce the weight. Talking about lightweighting in the electrification, that's something which we all need to continuously be abreast of. How we can reduce the copper content and reduce the weight using aluminum, or using higher conductivity copper wire, composites, make the platform itself lighter. And so these are some of the initiatives which every manufacturer today is working constantly. Also, when we are looking at lightweighting and we are looking at new technologies, we should also be abreast of the fact that the manufacturing technology also needs to undergo change on the assembly lines, and we need to make that entire system also work. So new material combinations would mean new manufacturing processes, which need to be also addressed during this process. Many of you would be aware of this fact that today there are manufacturers who are going towards gigacast, and this is a trend of the future, especially on the EV technology. And this is a kind of a big change from the traditional approach of building a BIW and doing the assembly and going towards a gigacast approach. This definitely reduces the number of parts, it reduces the weld parts, it reduces weight, uh, improves the noise level. And this is started by Tesla, now replicated by Chinese manufacturers. And this makes a complete methodology change. But of course, having said that, this is a cost impact which is which is there. So it's always it's about optimization of technology for the customer base, for the segments which you are, for the products which you are manufacturing. What kind of technology which can be absorbed by what type of product, and today from the lower end to the higher end, these are the various gamut of technologies which are available to auto manufacturers to actually scale up. Lastly, now I'd like to talk about when we talk about sustainability, it's important that we talk about the circular economy, when today in this age there are many new regulations which are coming in, and we also want to make sure that we are able to reduce, reuse, recycle, and recover parts. When it comes to end of life, in Europe there is this RRR as a regulation which is already there, and but in India too, I think we all need to work towards this. We need to reduce the amount of waste. We need to reuse the materials that are which are discarded, recycle, and also recover. So these are some of the things which we all need to work. And we also have today a EPR framework, which is now coming into India, and this is specifically, today we're talking about steel, tomorrow we'll be talking about batteries, where producer has a responsibility to establish and recycle and also, use that back into the process. And this is an ecosystem which needs to be developed, and all auto manufacturers are working, in this in a manner. And so, as Suzuki and Maruti Suzuki, we are also working towards this. That how we can use this Shushokitanbi in our manufacturing technologies, and during the use, and also setting up scrapping centers and scrap the materials, and reuse that reuse materials back into the production process. And these EPR guidelines give certain percentages of recycling to be done. And so that's something which is work in progress at this point of time. So I think a lot is to be done on the material side, on the design side, on the manufacturing side. And every engineer today has to strive that, okay, when I am today designing parts, I have to also ensure that, I move towards, I select materials which can be recyclable. I need to, increase the recycling content in the materials which I am using. I have to, design parts which are easily disassembled. I use the manufacturing process which use the least energy. I also need to focus that whatever product I make, it uses the least energy, and it should be easily dismantleable at the end of life, and then those parts should be recyclable. I think that's something which all of us have to strive, and every engineer today is working on this kind of a concept. And that's something which we, is going to ensure that we move towards a sustainable development for future generations. I think so. This conference today by Autocar Professional on lightweighting, I think is very significant, and it's something which we have been talking in the past too, and we have had lightweighting conferences, but that's something which we have to continuously engage, we have to continuously work and ensure that we all practice some of these areas, ideas into our processes and ensure that we create a sustainable we do a sustainable development for future generations. So thank you, Mayank-san, for having me, and I would like to end my presentation. So,
Thank you, Raman-san, for your kind words and for your excellent presentation. I think you've given us a holistic view on not just the materials, I think starting from design, then material perspective, and ending all the way to circular economy as well. I think in today's time, recyclability, as you said, with EPR coming in, I think it's very important, and every company now is looking at it from that perspective. So really, thank you so much for that insightful presentation. And with your permission, Raman-san, I would now like to take a few questions that are coming in from the audience. And I'll begin with the first question from Mr. Ramandeep. With a heightened focus on safety as well as the increased cost pressures, how are companies now managing to reduce weight while trying to achieve high crash ratings and meet costs? So could you also give us some grades of materials that we are seeing now increasingly being used in vehicles?
yeah, so I think as I was explaining in my presentation too, over the generations the vehicle weight has come down, but we are using high tensile steel and ultra high tensile steel in a big way, whether it's 590 or 790 or 980 for that also. So I think this is something which is a given today, that ultra high tensile steel needs to be used. We need to also see that the platforms are made stronger, but yet lighter. And all of this, of course, having said that, there is this misnomer which is there, that a lighter vehicle is not safe, but that's not true, definitely not. The lighter vehicle is because of the material which is used, but does not, mean that it does not have the strength. And today, every vehicle undergoes crash testing.
Right.
As far as the regulatory realm is concerned, whether it is offset or side impact.
Mhm.
And coupled with that, we also have the B NCAP rating today,
Yeah.
which does some additional, testing, which gives a rating to the customer to tell that, okay, what is the safety of level. But having said that, the minimum safety regulation is today available for all products, and this will keep evolving over a period of time. And I would also like to mention that a CO2 reduction objective is also very important
Mhm.
for the industry as well as for the customer, especially when we are looking at electrified technologies. Weight of the electrical parts or the battery consumes a huge energy, and reduces the range. We need to also ensure that the weight of the overall aggregates reduces, so that we are able to improve range. And today, customer is looking at in ICE vehicle for fuel efficiency and in the electric vehicle for range.
Right.
So as a combination, we need to ensure that we meet that objective.
Right, right. And not just EVs, Raman-san. I think in your presentation, you also showcased, the weight increase which comes in with CNG. And
Correct.
related to that, that is the next question from Mr. Ahmed, who wants to understand that what innovations can be expected in the area of CNG tanks to reduce their weight? And will the industry see some material innovations on this front?
So I think from CNG, I think CNG is today being widely accepted by the customer, and in view of the fact that the infrastructure of CNG today has grown, and Maruti Suzuki has almost 30% of the vehicles as penetration
Right.
CNG, and overall as an industry, it's almost 20%. So
Yeah.
I think CNG is becoming acceptable. But having said that, weight of the tank is something which you have seen in the presentation is high,
Right.
and can we move towards a lighter tank? And is the question. And composite technology today is available. It is being used in various fields. But that's something which is expensive. Work is happening, by manufacturers, along with suppliers, how we can, control the cost of that, how we can make that, bring it into mass production for, such vehicles. And also, it's not just about CNG. If tomorrow you're using, hydrogen blend or some of these things, automatically, I think we'll have to move towards a composite, technology. Yes, these are some of the directions which, auto manufacturers and auto suppliers are today working on. And yeah, the tank is one of the biggest component of a CNG vehicle, and composite is one way to.
Right, right. The next question is from Mr. Gaurav Saxena, who says that, with seats increasingly becoming complex mechanisms with all the ventilation features and electronic adjustment motors coming in, how can weight reduction be achieved in this particular area?
Same. I think it's a combination. It's a combination of various, aggregates in a seat. Seat frame is something, when we are looking at crash, we are looking at, NCAP ratings and other things. We are looking at ventilation, adding motors, adding ventilation. The weight would go up. Structurally, how we can reduce that by using more high tensile into the seats,
Okay.
lightweighting of that, change of the design so that it gives better strength, is one direction definitely. Second direction is in the PU itself. Can we look at another way of reducing? And when you look at sustainability, we also need to look at circular economy. We need to talk about PU and the plastic recycling, which we need to also ensure how we can do that. So, but coming back to this question, in seat, you need to look at all the three aspects. You need to look at the PU, you need to look at the plastics, you need to look at the metal. You also need to look at the motors. Can we use more a lighter motor, a smaller motor, and this is a constant endeavor. And smaller, lighter, neater, more beautiful.
Yeah,
is the direction. Yes,
Yeah,
that's the way. Any
right.
case.
Right, right. And also, Raman-san, you explained about giga casting. So what potential do you see of that technology, particularly from the India market perspective?
Well, it's done by one manufacturer, now replicated by a couple of more manufacturers in the high-end segments, okay, where such technology absorption takes place, higher battery weights with, and so it is possible in future, but it again depends on which segment you are playing in.
Okay.
And engineering in some way is all about optimizing various things. You need to optimize today. You're making a product for the customer. The price has to be right, and when you start from there, you work backwards. As engineers, we come back to what is the material cost and that, or what is the product cost, which should be, and break it down into aggregates. Each engineer of the aggregate is given a weight target, and from the weight target, then he has to derive the best weight and the best cost in order to meet the target cost. And so, in a ways, it's a very from our perspective, maybe it is at a very nascent stage. But in future, I think definitely there are some learnings which we can see how we can utilize that kind of methodology, how
Mhm.
we can find solutions which could be effective for us is something which is we need to think about.
But as a whole technology, you're saying that it's going to be more relevant in the premium segments?
Looks, I mean, that's how it is today. That's how it has
Hmm.
been now done, and and I would say something which has seen the light, but it is being replicated in the higher end. What I meant to say was that if some of those, not the entire gigacasting, but
Right.
some parts of it
Some
can be
elements of
utilized somewhere and in
right.
our entire process itself, integrated and
Right.
start reducing the weight, we need to
Right.
find that that thing. So
Correct.
that's something which we need
Correct.
to work.
Right. You need to imbibe the best
Yes.
practices into your
Yeah,
you
yeah.
know, meat
That
of the market.
methodology, it's a
Methodology.
methodology, it's a way
Right.
of manufacturing.
Right.
But
Right.
can we do that in a better way, in a different way,
Mhm.
which is cost effective? That's the challenge for the
True.
engineers.
True. True. Lastly, Raman-san, Mr. Rajashekar wants to understand how can the weight be optimized in electric vehicle powertrains? Just a few elements if you can touch upon.
Well, it could be the way you make the pack itself, the cell to module to pack to, you know, or you go in cell to pack, or these are some of the
Hmm.
things which are people are working on to
Right.
reduce the weight. Second is how to reduce the copper content. How can you go to
Hmm.
higher voltage? Is another method. Uh, Conductivity, how that can be improved. The type of copper which you use, can you
Right.
reduce that? Uh, uh, and also, extreme example, the pack on which you can, that's the platform, in a way, and then you build the vehicle over it. To
Right.
that extent, also some people have done that. So, but that's again on the higher end.
Hmm.
But I think the uh, the key point being that every kilowatt of hour of you know the battery weight
Hmm.
capacity which you require for the range,
Hmm.
how you can, because that will increase, to 20 kilowatt or 30 kilowatt or 40 kilowatt or 50 kilowatt, seeing that, they give a range of 300 or 400 or 500, depending on the type of pack. You want to reduce that weight. And when you are reducing that weight, you can reduce the weight of the structure what
Right.
is carrying it. You can reduce the weight of the other parts which are,
Yeah.
which is the braking system which is required. Everything is today somewhere, contributes, because
Yeah.
it's a weight which is in motion, which is
Yeah.
that energy which is needed for the motion, but also and the strength which is required for to stop it or turn
Yeah.
it, or those kind of things you need to work on.
Right. 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 With that, Raman-san, I'm afraid we have run out of time and really appreciate your coming over and giving us this insightful presentation. I think it was an enriching session, wonderful session. And thank you very much. Thank you for your time.
Thank
Really
you,
appreciate it.
Mayank, for having me. And yeah, thank you so much.
Thank you so much, Raman-san. Thank you. And with that enriching keynote address, we now move to the next session for the day, which is a panel discussion on the topic Global Trends in Vehicle Lightweighting. And I would like to introduce our esteemed panelists. We have Mr. Vishwanath Rao, who's the MD of Altair India, Mr. Alok Ranjan, who's the CMO, Vedanta Aluminium, and Dr. Lokesh Agrawal, who is the CTO of NBC Bearings. Gentlemen, very good afternoon, and thank you very much for joining us here today and taking out your time. Really appreciate it.
Thanks, man.
Yeah, so as Raman San has sort of very rightly set the context for the day, I think efficiency and safety are the two key drivers for lightweighting in vehicles. So I want to continue that and start off this conversation with maybe an opening remark from each one of you from the specialization domains that you have. If I can begin with you, Mr. Rao. So, if you can give your opening remarks around, lightweighting and from a design and development perspective, how are we seeing new initiatives or new methodologies coming in the design space itself when we are seeing, the topic of lightweighting becoming center stage in the automotive industry?
Yeah, hi. First of all, hi, good afternoon to everyone. Thanks, Mayank, for having me on this panel discussion. It's a privilege and honor to be, talking on this forum along with my fellow panelists, Alok and Lokesh. First, let me introduce my company. I work for a company called Altair. Altair is a global leader in three technologies: simulation, which essentially means we simulate different types of physics, which is extensively used in developing different types of products. We have very, very wide presence in the auto industry. Pretty much every auto company around the world, be it component manufacturer, system, subsystem manufacturer to OEM, uses Altair's technology for engineering their products. The second technology that we bring to market is in the area of computing, high performance computing, which again is a backbone to our simulation technology, because most of these are mathematical models that we're trying to solve, and solving is computationally very intensive and it requires a back-end compute infrastructure. And that's what we manage with our HPC technologies. And the third technology and the more recent addition to our portfolio is in the area of artificial intelligence, data science, and machine learning. The whole idea about having AI and ML built into our solution suite is to accelerate product decision making, accelerate innovation and engineering by a factor of 1000x. That's the kind of acceleration that we want to bring in. If simulation can provide you results in a matter of days, we want to have predictions done in a matter of seconds to minutes by building AI and machine learning models on top of simulation data. So that's essentially what we do. We are a 40-year-old company, very, very recently acquired by Siemens.
Okay.
So now we are part of Siemens Digital Industries Software. We are a Siemens-owned company. We have about 15,000 customers worldwide. In India, we are roughly about 1,000 people, have been here for about 27 years, and we have over 1,500 customers, I would say a third of whom are in the auto industry space. So that's a very, very brief background about our company and what we do. Now, specifically coming to the topic of lightweighting, Altair has been a pioneer in the area of lightweighting for many, many years. In fact, for the last almost 3 decades. Our origins in lightweighting started with the aerospace industry, where weight is very, very critical, because every gram saved makes the aircraft that much more efficient in terms of the distance it can fly or the amount of load it can carry. And many times aircrafts cannot fly if they are overweight. So our origins of lightweighting started in the aerospace industry. We were extensively involved in the Airbus 380 program. We had set up an optimization center in conjunction with Airbus in Europe, where we were essentially screening each and every part, each and every design of the A380 and trying to take weight of it and make it lighter and lighter. Just on the aircraft wing rib itself, we were able to reduce almost about 500 kilos. Okay, that's the extent of lightweighting that we did with the Airbus A380. So the origin started in the aerospace industry, when obviously then we took it to many other industries, automotive being one of the prime ones. The initial drivers for lightweighting in the auto industry was cost, because 100 grams saved on one part multiplied by millions of parts results in huge cost saving. Initially, it was cost. Then it became efficiency, performance, and more recently, I would say it's environment, net zero, sustainability. So these are the more recent drivers. The old drivers still continue to exist, but the more recent drivers are in the area of sustainability and net zero.
Right.
So all of this is achieved. The lightweighting and the optimization of structures is achieved by applying simulation, AI, and HPC technologies. So that's a very, very high level opener in terms of what we as a company do and how we have been associated with various industries.
Right, right. Mr. Ranjan, if I may come to you now, I mean, your opening remarks on the topic. I mean, how do you see aluminium emerging as a promising material, especially in the automotive industry from a lightweighting perspective?
Sure. So first of all, thank you, Mayank, and a very warm welcome to all the audience and my fellow panelists. First, let me introduce my company, my organization, which is Vedanta Aluminium, part of Vedanta Group. We are a large multinational company in mining, metals and mining. So it's a resources company. essentially in metals and mining. We are present in zinc, aluminium, lead, copper, gold, silver, oil and gas. And in all these businesses, we are among the largest producers in India and also the world. We were the first company in India to launch primary foundry alloy, which is extensively used in automobile industry in the year 2019. And since then, almost every automobile company today, they buy aluminum from us in some form or the other, essentially alloy wheels, but increasingly engine blocks and now EVs. So I think I was very intently listening to Mr. Raman's comments and how the shift is towards safety, efficiency, sustainability, and all these parameters, aluminum scores very well. In the sense, I think some of the key considerations today is lightweighting, because it not only saves cost, but also gives a larger fuel efficiency and lower carbon emission. So if I can talk about aluminum, which is roughly 2/3 of steel in terms of density, but it is infinitely recyclable, highly durable, and also corrosion resistance. So these 3 or 4 parameters make aluminum a very strong substitute for making various parts of any automobile. And we at Vedanta currently, we are reaching towards 3 million ton of aluminum, which is the largest in India and also 6th largest in the world. We have maybe 700 KT of alloys, which can go into various parts of automobile. So there are 3 products which we make from aluminum, which goes into various components of automobile. So PFA, which goes into this alloy wheels, then billets, which goes into making extrusion for the body parts, and then rolled product, which can go into sheets, which goes into various parts of the automobile. So again, in summary, today, some of the key considerations like range, like lightweighting. So aluminum is a very natural substitute, and we are very well placed to cater to the requirement of Indian automobile, which is growing at very fast pace.
Right, Mr. Ranjan, thanks for your opening remarks. I'll come to you, Dr. Agrawal. I mean, from an engineer's perspective, your thoughts on this? What are the innovations or the innovative techniques that you are deploying, in terms of design and development of components, like in your case, bearings?
Thank you, fellow panelists. Am I audible?
Yes.
Okay, thank you. So just to quickly introduce the company which I represent NBC Bearings. We are the largest volume bearing producer out of India. Almost now 30 years in existence, and we produce approximately 250 million bearings a year. Now, if we talk about lightweighting, even if we save 1 gram to 2 grams, you can see the impact it can create. The techniques which we use, since we cater from railway, industrial, automotive, and now aerospace, the lightweighting is a way of life for us. So when we look at it, the kind of thing which we do is, as previous fellow opening remark, performance and safety is the most critical. So in bearing world, these 2 are very, very critical. We ensure that we are not just looking at the lightweight, we are looking at the right optimized solution. And that's how we use the advanced analytical tools to make sure that we are getting the required life in the right envelope. So when we look at ourselves as a company, we are no more a product company. We are a solution provider, and we look at the component in which we are going along with to ensure that we are providing the right optimum geometry, optimum weight, optimum material, so that we do not compromise either on safety, on performance, or durability, because nobody likes it. At the same time, as we are speaking about, say, electrical vehicle, the range is a big question, and range is sometimes the direct function of the weight. And then the friction. We are anti-friction. So these 2 things which we always care, and we look at it, work with the customer, and provide multiple solutions. So what we have already released some kind of a methodology in which we provide the optimized geometry, either through the different heat treatment, different material, as well as coating solutions. all those things contribute to get the right performance in the given envelope.
Right.
We have worked considerably with a lot of customers to ensure that it is not just bearing as a component, but as a system which we work with. So those
Right.
are the things which we are looking at it, whether it's an aerospace field, whether it is a automotive field, industrial and railway, typically they don't care too much about lightweight. They care more about performance. But
Right.
these two industries, we have been a leading solution provider.
Right. 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 Thanks, Dr. Agarwal, for your opening remarks. And till I take, I proceed further in this conversation, Dr. Agarwal, I believe there's some glitch in your audio. So if you can just try and maybe, try and rectify that.
Sure.
Your audio is very feeble, actually. Although we're able
Okay,
to hear you, but we're not able to hear you properly.
let me do one thing. I come out of my Bluetooth and jump straight onto the computer audio and go in a little noisy place. So you can continue and I'll fix
Yeah,
it in
if
a
you can
minute.
just rectify it in the meantime, and I'll proceed with
Sure.
the discussion. Mr. Rao, if I can come to you, I mean, taking from where Dr. Agarwal just left, I mean, these different scenarios of developing and designing these components. So, if you can give me like broad examples, the things which are the key elements which are being tapped into in a vehicle. There could be different domains within the vehicle which are the prime examples right now to save weight.
Okay, see, there are various ways in which you can save weight. One way of saving weight is replacing your incumbent material with a new material which is lighter, stronger, more durable. It could be various different types of high steel alloys. It could be aluminum. It could be magnesium. It could be titanium. It could even be things like, carbon reinforced fiber or, glass reinforced fiber. There are various types of material options that are available today. So that's the first. And that's a more easier, way of addressing the weight problem, in my opinion. Okay.
Mhm.
The second way of addressing the weight problem is to ensuring that you have material in the right place. Okay. Having more material does not mean you have a better design.
Mhm.
Okay. That's something that generally people take a very, very high level of factor of safety and make their structural components, bigger and thicker with the assumption that if it is thicker and bigger, there are very less probability of failures. But if you want to really get an optimal design, you need to have your material in the right place. So we call it called as minimum weight design.
Okay.
How can you use the minimum amount of material and at the same time be able to deliver the best possible performance in terms of the structural integrity, in terms of the life, in terms of the durability aspect, in terms of noise and vibrations, in terms of occupant safety? It could be any parameter, right? So how do we use minimum amount of material and still be able to produce the best possible design is the problem that we try to solve as a company. Now, how does this work? Altair has been pioneering this technology called as generative design.
Mhm.
Today, you hear of the term generative AI, but
Yeah.
we have been doing generative design for the last 25 years. Which means, how does it work? Okay, a package space that is available for you to design either a component or a system or a subsystem, right? You have your fixed points or hard points, which essentially are the places where other components are going to be molded. For example, take a knuckle. A knuckle is going to be connected to four or five different other components. And those fixed points are already fixed. You cannot make changes. It's the intermediate area which connects these points is where you have freedom to decide how you can lay down your material, right? So what we do with our technology is we provide a package space to the software.
Mhm.
We identify designable areas and non-designable areas, essentially the joineries and the points where you're going to join to other components and non-designable areas. And the rest of the area is what is defined as the designable area within the package space. And then, of course, we impose all the loads and the boundary conditions. What are the different types of loads coming on this particular structural component, right? And then we define some constraints and objectives
Mhm.
to solve the problem. My objective is to get a minimum weight for the design. And my constraint is that the maximum stress anywhere in this component cannot exceed a certain value,
Mhm.
or the frequencies have to be within certain range, or the life of the part has to be within so many cycles. You can define various constraints. Now, these are the inputs to the software. Now, what does the software do? It generates a design on its own.
Mhm.
Okay, keeping all these inputs in mind. Your input is basically minimum weight with various constraints
Right.
and the loads and boundary condition. It tries to come up with the conceptual design. Is the design 100% right in the first go? Maybe not, but it gives you a direction. It gives you a concept.
Mhm.
Okay, is the design manufacturable in the first go? Absolutely, it is not.
Hmm.
But it gives you a direction. Okay, the beauty of this is essentially it traces the load path. Okay, the technology traces the load path and understand which direction and what is the flow of the load within that package space, and tries to put material there and essentially carve out and remove material from all the other areas. Okay, so it is a material removal technique, just like how we do, for example, milling or grinding or any of those. It's a material
Yeah.
removal technique. You give a chunk of material with design and non-designable areas. The software keeps removing material from areas where it is not required and only retains the material in the area that is required. So this is a first stage conceptual design that it produces. Now you can also impose various manufacturing constraints when you're trying to generate the design. You can say, I want this design to be a cast component. Okay, or I want this design to be a forged component or an extruded component or a plastic molded component or even a 3D printed component. Okay, you can impose manufacturing constraints. You can let the software know, I'm going to develop this part or I'm going to manufacture this part by using plastic molding. Okay, the software understands what kind of design can be moldable, plastic moldable, and it recommends a design to you which is actually manufacturable.
Okay.
So you're taking care of getting your design right the first time. You're ensuring the weight is the least. You're also ensuring you're achieving your manufacturability goals.
Right.
Okay. So this is the technology that Altair has been pioneering. We call it generative design. If you can call it generative AI design as well if you want to. Okay. So this is something that
this is akin to the artificial intelligence foray that we are seeing in today's time, right?
yeah, it is. I mean, it's see, this is something which has been there for 25 years, but it's
Right.
just that today it's called with a different name.
Yeah. Yeah.
Right. So generative design has been there as a technique for many years.
True.
The only thing that we are doing here is we are not using historical data to make predictions. In a typical data science AI platform, you use historical data to make a predictions. Here we are trying to trace the load path and based on that trying to create a design.
Right.
Okay, but the system has the intelligence to understand the problem and create a design. It's an intelligent system which can create the design.
Right.
So this technology is called as OptiStruct, which Altair developed about 35 years ago and has been used, and pretty much every auto company today around the world uses it to create the design. So with a combination of having the material in the right place and having the right kind of material, you can really achieve great results in terms of lightweighting. And that's essentially what we have been doing for a long time.
Right. Right. Mr. Ranjan, I mean, we've talked about aluminium being a good potential alternative to steel in the automotive industry. Now, also aligning to that, with that also comes the challenge of cost and manufacturability. So your thoughts on that, how do you see, what sort of growth uptick do you see for aluminium in this space going forward? And, simply because cost continues to remain a big challenge for all OEMs.
So it's a fact that the cost is an important criterion, but then there are three stories, three angles, which is very strong in favor of lightweighting, essentially. So when you say aluminum, why would you use aluminum is essentially for lightweighting. So there is definitely cost angle, but there is a safety angle, there is a range angle, there's total cost of ownership angle, and there's also sustainability angle. So in all these parameters, if you see, for instance, there's typically 4 to 5% carbon reduction, 22% mass saving, and roughly 5% cost per mile reduction when lightweighting is done. It could be through aluminum. Aluminum is increasingly an important source of lightweighting. When you talk about speed or acceleration, which is also an important criteria, aluminum vehicles have far better pickup and acceleration thanks to the lower mass. And therefore, there's an edge. And also, since it is durable and recyclable and corrosion resistance, the cost of maintenance is typically on the lower side. Typically it could be 10 to 15% lower as compared to its alternative. Range we just spoke is very critical, and if you reduce the vehicle weight by 10%, roughly the range goes up by 8 to 10%. So again, if you, depending upon the fuel costs, which varies from geography to geography, it has a significant impact. Then if you talk about even the battery life, aluminum use leads to much lesser frequent charging cycles, much better longevity of battery. So battery, because energy storage, as all of us know, is an important criteria. So again, there itself, aluminum leads to lesser charging cycle, therefore, which means larger longevity. So there are multiple factors. While upfront costs may look to be higher in term when you use aluminum, but if we take into account multiple factors and total cost of ownership over life of the vehicle, then all these advantages cancel out the upfront cost which somebody has to pay for aluminum.
Right.
And also, I mean, if you think about it, aluminum is infinitely recyclable. So through closed loop recycling, you can salvage almost 100% or maybe more, depending upon the prevailing prices. And aluminum is increasingly in demand. Therefore, supply is also getting restricted. So, I mean, salvage value is much higher as compared to steel. So there are multiple parameters which we feel is very strong in favor of aluminum, which makes a very strong case.
Right. You call it the metal of the future, Mr. Ranjan. So, what sort of roadmap do you see for aluminum adoption going forward?
So we see very, very healthy growth rate for aluminum. But if you look at it, India is already the third largest automobile market in the world. But in terms of per capita consumption of aluminum is 1/8. If you talk about aluminum usage per vehicle, India is roughly 70 to 80% of global standards. But having said that, there are a lot of tailwinds. First, from the policy side, government is encouraging lots of policies regarding the FAME, I mean, incentives which government has announced, or they have taken a target of having nearly 70% of commercial vehicles or 30% of passenger vehicles as electric vehicles by 2030. So there is a policy push, there is a sustainability push. And if we rely on the data coming from other countries like China or Western world, we see significant growth in terms of EV, which again means up to 80 kgs per vehicle more aluminum usage. And again, we are very well placed. We are investing in the right alloys. We are augmenting our capacity, both smelting and cast house, so that we have the right product which will cater to the automobile of all sizes, both ICE engine as well as EVs going forward.
Right, right. Dr. Agrawal, like Mr. Ranjan just mentioned, I mean, there are a lot of tailwinds towards these alternative materials, not just aluminum, there are, other composites that we are looking at. And also this drive towards sustainability, is also driving the use of a lot of biomaterials as well. So your thoughts on that, and, I also want you to touch upon the challenge that we discussed, the cost and the manufacturability angle. So, as a tier one supplier, how do you navigate this situation?
Yeah, is it audio is better now?
Much better, yes.
Okay, thank you. So yeah, I think so. Composite material we call sometime in the dual material. So basically, if you look at it, bearing takes the load, right? So we identify the area where the loads are not taken. Can we use a different type of material, which is a lightweight, but at the same time does not compromise the fatigue. Second thing which we do in these cases, if you look at it, the cages. So we have started using the cages which are non-metallic.
Okay.
And that's where the whole weight game goes down. The advantage which we get, especially if you're going for very high speed bearing, the weight goes down of the cages. That means the centrifugal force is low. That means the opening up is easy. So it actually increases the life. So we are seeing a more and more uses of what we call polyamide cages or special plastic cages.
Okay.
That certainly calls for different challenges in manufacturing, the volume, as well as at assembly level. The second piece which we do in these cases is, as I talked about, is a dual material, which is generally applicable for very large bearing. For a smaller bearing, we don't have that cross section that I can afford to have that. So what we have come up with is something called integrated flange bearings, also called as a Gen 3, Gen 4, where we look at, can we combine the components and so that we are still lightweighted and still achieve the performance.
Right.
The next thing which we have done is in sensor bearing the sensor, the entire envelope.
Mr. Agrawal, I believe there is some network issue at your place. So we're losing you intermittently. Dr. Agrawal? Yeah, you're on mute actually. Okay, so yeah. Yes, okay. I mean, till the time this issue gets resolved, I think there's some network issue that we are seeing at Dr. Agrawal's end. So I'll come back again to you, Mr. Ranjan. So, you mentioned that you're doubling down on your investments in terms of capacities and all. So if you could just give us a quick overview there, what sort of capacities do you have? And also in terms of the local availability of the right aluminum grades for the auto sector. So where does India stand there? And, what are the challenges that could the industry face in the future?
Sure. So I think we are fortunate to live in India, which is endowed with a lot of natural resources. So we have all the ample raw material which is required to make aluminum.
Right.
And we also have a captive market which is growing at a very fast pace.
Mhm.
So if you look at it, India's total aluminum requirement is close to 6 million tons. And currently the production is 4.2, and we are augmenting our capacities to take to close to 5.2 million tons. So in terms of primary aluminum requirement, we have sufficient capacity to cater to entire requirement of India, and we are going on adding capacities. Our idea is to have a fully integrated with our own raw material, with our own mines of coal, bauxite, or have our own refinery to make alumina, and finally smelter to make aluminum. So it's a completely fully integrated aluminum operation. And in terms of primary foundry aluminum requirement, I mean, India typically is a 200-250 KT market, and our capacities are much beyond that. So I just want to take help of this forum to reassure that we have the right aluminum and the right products of various grade which is required. Not only that, we are investing in adding our capacity. So going forward, in view of increasing demand, so whatever aluminum will be required, we'll be in a position to cater to that. Second, we also launched 2 brands of aluminum, which is very green, because it is made using largely renewable energy. So in terms of carbon footprint, they are the cleanest, greenest aluminum available anywhere in the world. We also, we launched a brand called Ristora and another brand called Ristora Ultra. So Ristora Ultra has a lot of recycling component as well. So again, we were the first company in India to launch green aluminum brands, and we are already selling this to nearly 60 countries in the world. Today, almost all automobile manufacturers in the world, through their ancillary units, because aluminum essentially goes into alloy wheel manufacturing, they are our customers. So again, just a reassurance that we are there, and we can take care of any aluminum requirement by any automobile manufacturer in India.
Right. Vishwa, if I can come to you, I mean, we're talking aluminum here. So, like Mr. Ranjan already mentioned about the angle of sustainability and circularity in this. So from your perspective, when you talk about your design tool, so are we now seeing more and more of development happening from a circularity perspective? I mean, you're looking at recyclability right from the conceptualization stage itself?
I cannot say so about because recyclability, it really depends upon what material you're going to use, right? A material like aluminum, like Mr. Ranjan was mentioned, is completely recyclable, right? But if you're going into other areas, I mean, there are areas where, we have been able to build or design and optimize, for example, something like an instrument panel by using highly recycled material.
Right.
In fact, there are cases when trash has been converted into automotive components, right? So those kinds of designs are being developed. Our role essentially is to help optimize the design, improve the design, and bring in efficiencies for auto OEMs to develop this design in the shortest possible time frame. Right. So that's our role. But where we bring in the sustainability aspect, as I mentioned, is to create the lightest possible design. I can quote some examples. For example, if you look at electrification, has brought in tremendous amount of opportunities for creating new platforms and new designs.
Right.
A traditional, ICE vehicle, the architecture of body in white is something that can be used for an electric vehicle, but probably not the most efficient way of using it. So the technology that we have, and we have built a process called C1, 2, 3. C stands for concept 1 and 2 and 3. Okay, it's a three-stage process to create a completely new architecture for a body in white of an electric vehicle. Okay, because the load distribution, the packaging is so different in the case of an electric vehicle.
Right.
Again, you start with a clean sheet of paper. You give the designable and non-designable regions with the new packaged space because an EV has a completely different type of packaging. And from that, we are able to create a completely new architecture for a vehicle, which is the lightest possible architecture that you can create. Right. So every leading OEM in the world, whether it is Mercedes, Ferrari, Porsche, you name it, Jaguar, Land Rover, including Indian OEMs, have deployed this technique in trying to create a completely new architecture for an electric vehicle platform. Right. And all of this also is very modular in nature. Right. You create an architecture, you can adopt the same architecture for different variants. It could be a sedan, it could be a SUV, it could be a hatchback, it could be different variants of vehicles. Right. So that's where we bring in all the sustainability aspect in terms of being able to use less and less material, in terms of being able to make it lighter and lighter, so that your efficiencies are much better, your range is improved, consumption of fuel is lesser, the emissions are lesser. So once you reduce the weight, then it has an impact on many other things. You can carry more on the car. The impact is just tremendous. So that's the sustainability aspect that we bring. If you ask me in terms of recyclability, we can only aid companies to fasten the development process with recycled material. So that's the role that we play.
Right, right. And I also want to touch upon another element, Vishwa, on this AI. You mentioned that the tool, the OptiStruct that you were talking about, is more of a generative design tool. But are you also now infusing some AI capabilities into your software solutions so that you can also go back and look at historical data and then also suggest more possible alternatives?
Absolutely, plenty of AI capabilities. So if you look at the typical, the design paradigms that we have had over many years, we call this the fourth paradigm. The first paradigm was experimental. Second paradigm was based on calculations, hand calculations, and empirical formulas. Third paradigm was based on simulations, mathematical modeling. Fourth paradigm is based on data. Okay, data driving the design is what we're talking about today. A lot of engineering decisions can be taken just based on data. Now, what kind of data are we talking about? If we talk about a typical engineering process, companies have been doing simulation for decades. Most of the companies would have at least 2 decades of simulation data.
Right.
We are trying to use all of that historical simulation data to build machine learning models and being able to predict with those machine learning models.
Right.
Okay, so what is the advantage? It's nothing but efficiency and speed. We can accelerate design decision making by a factor of 1,000, as I mentioned.
Okay.
If something was taking you a day to simulate and take a decision, we could do that in a matter of minutes to seconds today.
Right.
Okay, that is one area. The other area is you have so much of data coming in from the field. Today, sensors are easily available. 15 years back, 10 years back, nobody had sensors in their vehicles. Today, every vehicle has hundreds of sensors mounted on them.
Right.
Everything is connected, right? So the data is going into the cloud. So we have access to all these data. So with these data, again, you can build models to get a lot of insights to understand how your vehicle is performing, what kind of conditions is it operating in, what is the behavior of the driver across various geographies, various demographies, how do you create new variants, how do you improve the design to address various use cases. You get so much of insights.
Right.
And of course, it gives you, triggers in terms of trying to understand if there is going to be a critical failure in the vehicle. What is the state of health of your battery? What is the state of charge? The possibilities are just unlimited in terms of what you can do with AI and data science, right? And the third area that we are looking at is on performance testing. Traditionally, companies have relied on testing for homologation and decision making. Homologation is largely driven by testing. If you go to a homologating agency like an ATRAX or ARAI, it's mostly based on simulation data is of course considered, but the final sign off is made on testing, right? So testing again generates tremendous amount of data.
True.
There is historical data available with most of the OEMs. So we are trying to use all of this historical data to again build models and make predictions. If I change a design, do I have to run one more test routine? Maybe not. Right? The AI model will be able to tell you if this design change is made or this material change is made. What is the likelihood of this particular part failing? When will it fail? How many cycles will it run? All of that information can be obtained through AI models today. So those are the areas in which we are working on the design and development side specific to auto industry. But as you know, the use cases for AI is just way beyond all of this. It can be applied in any area, whether it is sales, marketing, production, manufacturing, supply chain, finance, you name it. AI can be applied in any area. Wherever there is data, you can apply a data science model, build a data science model.
Yeah, absolutely. Yeah, we're almost at the fag end of this conversation. Dr. Agrawal, I'm not sure if we've been
I'm
able
just
to solve
wondering if this is better or not.
Oh yeah, this is
Yeah,
much
if
better.
it doesn't, then we will just come out of it because my network still shows unstable.
Yeah, no, this is fine, Dr. Agrawal.
Yeah.
So
So
you
I'll
want to
just
complete
sum
your
up
comment
from
that you were
last
making?
2-3 minutes what I just heard. Because I was talking about integrated flanges. I was
Right.
talking about sensor bearing. I think Mr. Vishwanath just touched upon that. The sensor bearing are the one which gives a critical input on a prognostic capability.
Right.
Also gives the input to digital twin that helps us in removing the safety factors, hence the materials saving as well as lightweighting. Because now we are able to build the physics along with the data to not only predict the bearing is bearings is started becoming spurious or the failure has started. That doesn't mean it has stopped the functionality or the performance. We have seen the cases that after the signal has changed, it has gone all the way till 6 months. So we have done all of that work to really reduce the safety factor and also change the interval. So in turn, what we are doing is we are saving the material. We are also reducing the carbon footprint.
Right.
So those few factors have come into the product. As Vishwanath talked about it, yes, I've used the tools long back when I was in simulation world, OptiStruct. And we use the similar technique to make sure that the sizes are optimized in a way that it is, and sometimes we give solutions which are not symmetric in nature because the load patterns are different. And accordingly, the sizes are given using simulation tool and of course followed up with the testing. Now, one more criteria which we use, we typically talk about material, but along with material goes the heat treatment or the material properties mechanically. So there is multiple things which are done even at the material heat treatment level along with material to make sure that we are getting the right durability, performance, and life in a minimum weight. So that's what I thought I'll sum it up. What we are doing overall on the lightweighting side.
Right. No, great, Dr. Agrawal, and thank you for summing it up. In fact, for me as well, I think I would want to close this panel discussion here and, keeping room for the two presentations that we have after this. But I think it was a great discussion, and thank you, all of you, Dr. Agrawal, Vishwanath, and Mr. Ranjan, giving us perspectives on aluminium, particularly coming in there from you, Mr. Ranjan, from Vedanta. Vishwa, your inputs on the design and development innovations that we are seeing in the industry right now, how different tools, like you mentioned, AI coming in and generative design is sort of helping the industry in trying to identify the places from where we can cut the slab and we can reduce weight to become more efficient. So really appreciate all of your joining, and thank you very much for taking out the time. Really appreciate it.
Thanks for having us.
Thank you. And with that, we would now move to the first presentation session for the day. The presentation is going to be on the topic lightweight solutions for the body shop, which is going to be presented by Mr. Dennis Suave, Global Product Manager, Body and Paint Shop Adhesives and Sealant Sika, and his partner, Mr. Dobrivier Jovanovic, or fondly called Bobby, Global Product Manager, Reinforcers Sika. Dennis and Bobby are experts in the field of vehicle lightweighting, and today they will be taking us through their presentation, which talks about some of the solutions that Sika has in the offering for the automotive industry. Dennis, over to you. Dennis and Bobby, can you please unmute your...
Just a moment.
Yeah, okay. I think there's some technical issue that we are facing here. Shouldn't take much long, so we'll request everyone's patience through this. Once we find a solution to this, we'll just go ahead with this presentation. Just a few moments. And in the meantime, I would like to request the audience that if you have questions, please keep sending them in the Q&A box, and Dennis and Bobby will be keen to take them up after the presentation gets over. And whatever questions that we've been able to unanswer to the audience, we'll try and go back to our presenters, be it the keynote presenter, Mr. C.V. Raman, or in fact our panelists from the last session, and we'll definitely try and get back to you with the answers to your questions.
Can you see the presentation right now?
Yes, yes, we can.
You can see the presentation.
Yes.
All right.
Yeah, please go ahead.
Okay. All right. So, thank you very much. I think we solved the technical issue at the beginning. Thank you very much for giving us opportunity today to talk about hybrid and lightweighting technologies, very specifically Sika Power and Sika Reinforcer. And Dennis and myself, we are going to share the computer and to go to the presentation. So the topics of today definitely is lightweighting with the Sika Power products, then some challenges and outlook, which we have, definitely lightweighting with Sika Reinforcer products, and also then one of the business case, which Dennis is going to show later on. Sika has more than 30 years experience with the lightweighting. Very specifically, we have many examples, the car manufacturers and OEMs around the world who are manufacturing the vehicles and specifically concentrated to lightweighting. We have examples where we can reduce the weight of the vehicles even up to 100 kilos per vehicle by model change. Here specifically, we have Sika Power crash durable and structural adhesives, which are key contributors for automotive lightweighting design and multi-material joining. As well, we have Sika Power hand flange materials, which are containing glass beads, and where we can definitely help to solve the topics which are related to hang-on parts in these regards. As well, then anti-flutter adhesives, the Sika Seal products are outstanding in the preventing bond line read-through, so-called BLRT. And of course, then Sika Power sealants, which are providing extraordinary corrosion, very specifically by water tightness areas. So we are bonding today more than 30 million vehicles around the globe. And what is extremely important to say is, I'm not going here in the details, but we have different philosophies of the car manufacturers. And as you can see here on the car, the adhesives are actually everywhere. Definitely by small using of the adhesives, you will find out a few meters of the adhesive, and by extensive use of the adhesive, then you will find more than 200 meters of the adhesive length per car body. I will give you here an example regarding the battery electric vehicles, very specifically because this is one of the mega trends, but as well as a motivation then to move ahead and in the direction of low bake or low temperature bake of the body shop adhesives. In this example, we have been working with the forward engineering together, and we have IC Seal. Here you will see then the simulation with the side pull impact, and when we are looking to combustion engine vehicle side impact, then what we see here is definitely that the battery which is reflected is the edges of the batteries are defected, and there is always a possibility that the battery catch a fire, and this is not the way we want to go. These are the critical areas which we see then by the battery module, specifically by the battery frame. By battery electric vehicle seal, there is less intrusion, and there is no module damage. When we see then here the very specifically reinforcing area on the right side, and the battery is, when we look at then when we look at there in the design, and there is no battery frame defect. So it means that there is a great protection of the battery in the floor of the vehicle. Furthermore, here there is one of the challenges very specifically, and this challenge is due to the fact that the rocker area is getting much bigger. The energy which is in E-coat often is not enough to cure the adhesive. So on the left side, we see then IC seal, the standard, which is steel, and on the right side, we see steel and aluminium profile inside. And when we make a temperature simulation, which you see right now, is that on the left side, then all the metal parts and adhesive, of course, itself are getting enough temperature. And what we see on the right side is that some parts, specifically inner parts, where is the aluminium, are reaching much lower temperatures. There is a weight effect, definitely, and there is much more energy needed in order then to cure adhesives. One of the next challenges, general, is by the multi-material design, is so-called thermal expansion delta alpha. So on the left side, we see then the standard body shop process, where we have oily substrates, adhesive application, joining process and fixation, whereas the temperature is 15 to 35 degrees centigrade. Going from the body shop, then where also adhesives are applied, going from the body shop to the E-coat, where we have E-coat bed by 50 to 65 degrees centigrade. And then finally, the final stage of the materials is E-coat oven or paint oven, but here specifically E-coat oven, where our materials are getting the final curing and the final function. Here, what we see is actually that we see that by carbon fiber, we don't have any expansion. By steel, we have expansion of 1.9 millimeters per meter, and then by aluminium, 3.6 millimeters per meter. So here you can imagine then by the big side walls of the vehicles, which are between 3.5 and 5 meters. Then if we have the multi-material design, then there are certain challenges in terms of how to bond those, and our solutions are the materials, very specifically Sika Power MBX technology, which has been specifically developed to solve the delta alpha topic. So here I would like to hand over then to Dennis.
Okay, thank you, Bobby. So you have seen the presentation from Bobby showing how we can bond different material together, aluminium, steel, and so on. So the key in a good design of a car body is, of course, use the right material, aluminium, steel, or plastics. But the key is how you will bond the component together. And here, so after the bonding example, I will show you some application of structural parts. These structural parts are based on a plastic carrier made of a simple polyamide material with a glass fiber reinforcement, plus another molding of a material based on epoxy, which will expand in place with the E-coat oven. So we have two types of application that we can make with this material. So the first one in the elastic domain of the part is local stiffness improvement. So by localizing some parts inside the car body, we can reinforce the complete body and help the different materials, steel, aluminium, to work better, smarter. And then if we use the materials of the parts in certain area that we are now in the plastic domain, we can use them to reinforce and crash the car body. So using the tools shown by Altran previously, we are able to propose some optimization solution. Here I will give you some example which drive to weight reduction. Here, for example, we want to increase the stiffness of the D-ring of a car. With a CIA topology optimization, we can define where we can apply this part and contribute to a stiffness increase. So, of course, with the design of the parts will be made with the help of CIA tools. And at the end, we can offer some application. For example, here we have added 7 parts per car. Plus 2 parts for the version with panorama roof, which is weaker. The full package of parts is 2 kilograms, but we increase the torsional stiffness by 3.8 hertz. Another solution here, what we can propose to the customer is to reduce the weight of the parts by diminution of the metal thickness and compensate the decrease of stiffness due to the metal reduction with an addition of structural parts. So you can see here the reduction of the different metal sheets. At the end, we achieve a reduction of almost 6 kilograms of the steel weight. And the Sika package was 1.4 kilogram of plastic parts, and we reduced the mass of the car by 4.4 kilograms. So these are solutions we can provide to the customer. Here, so you know the plastic component, we don't want imperatively to substitute aluminium or steel. Alone, the material, one is lighter than the other one and so on. But the combination of the different material make the design smarter and lighter at the end. So here we have compared the reinforcer technology, the plastic parts with aluminium, with steel, and so on, and it drove us to define a new solution for the seal application. So you can see here. So it's a combination of steel cold draw profile with some parts placed at a very key area. So with this system, we can solve some issue that we can meet in this area. First one is, for example, the thermal expansion of an aluminum profile in a steel body. The assembly of an aluminum parts in a steel body can be very, very simplified with this solution. With this solution, we have a very good access of the heat inside the seal to cure the E-coat and the parts itself and reinforce the body. These are solutions that we can provide to our customer. We just need a common work with the customer. And for example, this solution drove us. So, wait a second. So this solution, for example, we compared with an aluminum profile. With this solution, we reduced the weight of the car body by 3 kilograms, and we decrease the global warming potential of the solution by 57%. So, as I said, the way to use the different material together can drive to weight reduction at the end. So I'm at the end of my presentation right now.
Thank you, Dennis and Bobby, for giving us this presentation. And may I request you to please stay back and answer a few questions that I can see in the chat box. I think they are specific to the Sika reinforcer. And if you can just go and, if you could respond to some of those questions. I could take just one from Mr. Rajendran who tells, is there any adhesive available for polypropylene material?
Yes, there are also adhesives which are available for polypropylene. In some of those cases, then we need also some treatment because of polarity of the material, but there are also adhesives which are available for polypropylene. Yes.
Okay, right. Okay, yeah. Now we can see the both of you. Yeah. Great. I'll take another one, just the last one in the interest of time. This is from Mr. Rengaraj. He asks, with the increasing use of Sika reinforcer epoxy-based expandables for BIW cavity, what validation do you have on their long-term dimensional stability and mechanical contribution?
So this technology is in place since many years, and more than 30 years, and so we have now a good experience on the durability of the material, of the part, and of course we are fulfilling all durability or aging tests to be done in the automotive industry. It's a very standard one. And so we can provide, of course, the more targeted input if they ask directly to us. But these are solutions which are validated right now.
Right. Just one more, Dennis and Bobby. This is from Mr. Satish. Is Sika a replacement for traditional fastener fixations?
Sika, so in terms of adhesives, definitely, we need other technologies and other fixations due to the fact that adhesive itself cannot keep the parts together. So in this particular case, we need definitely spot welding, we need definitely riveting, we need all the traditional technologies. And this is something where adhesives are contributing the best, but definitely the adhesive itself at the moment cannot be used alone due to the fact that we need all those. What is happening is actually that due to using of adhesives, the number of spot welding points or number of rivets is massively reduced due to the fact that those are not needed in that amount by so-called mixed joining technologies, where we have mechanical fastening and chemical as well at the same time.
Right. Great. Thank you so much, gentlemen. I'll end this presentation session right here. And I would request you to please answer a few questions that you can see in the Q&A box, which are specific to some Sika products that you showcased in your presentation. And with that, I would now like to move to the next presentation, which is by Pioneer India Electronics. This is going to be on the topic green speakers, to be presented by Mr. Rachit Khandelwal, who is the DGM OEM Technical Solutions, Pioneer India Electronics. And again, the same drill, I would request the audience to share their questions in the Q&A box. And this is the presentation that holds us between the fireside chat, which is lined up after this with Mr. Anand Kulkarni of Tata Motors. So Rachit, over to you, please.
Yeah, hi. First of all, thank you for the Autocar for arranging this session, and a warm welcome to all the panelists and the host who have joined this meeting. So, is there an issue with the camera?
Rachit, I believe there's some issue with the video here. There's a lot of, now it's slightly better.
Not sure what's the issue.
Rachit, could you try removing the virtual background? Maybe that's causing the concern here. Yeah.
Yes, I think so. Yeah.
Much better. Yeah.
Much
Please
better.
go.
Okay. Yeah. So again, thanking Autocar for arranging this session, and thanks to all the panelists and hosts for joining this. A warm welcome from my side. So today we will be discussing on the low weight speakers from Pioneer. So Pioneer, being an 85-year-old organization who specializes in audio solutions and speaker solutions, have always worked on the innovations. So here we are talking about an innovation which is like the need of an hour. If I talk about the today's era, wherein in the vehicle on daily basis, the number of speakers are always increasing. Earlier, there used to be a standard set of, I would say, 4+2 speakers. Now we have solutions wherein the number of speakers are increasing tremendously to 8, 10, 12, and more. So I would say what I can feel in need of R is to reduce the weight in the speakers, and then later we can also work on the technology how to drive them. So Pioneer has collaborated along with Clipple. Clipple and Pioneer have designed a speaker which we called is the speakers controlled by Clipple sound. So now the benefit of these speakers are, first of all, they are reduced in size and the weight. They have, since now the size has tremendously reduced, it will lead to the reduction in the cost. And then when it is controlled by the software, we can have the better performance, better efficiency, along with the support of overload protection and live diagnostic. Now, if I take few examples and try to collaborate how it will work out in the vehicle. For example, there's a 16 centimeter speaker, which is a standard speaker, which is used by most of the OEMs. Now, if I design a green speaker for the same performance and the same efficiency, I can design the same speaker in a 10 centimeter 290 gram. So if you see here, the size has been reduced by 40% and the weight has been reduced by 55%. So now we are getting the same performance, same efficiency, same sound experience with a smaller footprint, smaller boxes, slimmer design, and more freedom in packaging. Now, this is where the OEMs need to work with us. We can always help them in designing the right speaker and reducing the weight of the vehicle tremendously. So if I talk about 4+2 speaker configuration, which is a standard configuration, here you can reduce around 1200 grams only from the vehicle just by changing the speaker design. Second is, if there's an existing vehicle wherein there's a need to have this reduced weight of the speaker, we can again design a speaker which is a 16 centimeters speaker to a 16 centimeter speaker. Here, if I compare from a neodymium or a ferrite type of speakers, we can see the weight has been reduced from 670 gram to 580 grams, which is close to 15%. 1300 gram going to 995 gram, again close to 30%. So in this, what we are achieving is we are getting the same excursion, but with a smaller BL and with also a smaller TSD. Same mechanical protection, what we can offer is like in terms of excursion, since we are controlling it through a software, there's a limiter setting which can be set to save the speakers also. And now, since it is software driven, we can get the maximum output out of the speakers. Now, talking about the additional capability which we can be given based on the speakers is, first of all, since the TSD has been reduced tremendously, we can get the better frequency response from the speakers. Earlier, the door woofers were limited by high distortion and high TSD at 60 Hertz. Now we can extend the speaker performance till 30 Hertz or 40 Hertz as well. This will help us in getting the better bass performance, and we can even look for the initial vehicles wherein we can remove the subwoofer also. Along with that, since now the speakers are capable of playing frequencies which is low in terms of frequency, we can also reduce the ANC or the RNC. The speakers are capable of delivering a equal amplitude 180-degree phase shift, so it can cancel out all the distortions. Now, if I talk about a hi-fi system, the basic requirements is high latency or low latency with high processing. So now this collaboration with Clipple is enabling that. It's an SDK residing on the head unit or the amplifier. It can be integrated into the current structure as well, and then it can deliver the best performance. Now, Now, the major problem which we are seeing in market right now is once your speaker goes bad, the user is not able to understand the problem. Whether there's an issue with the speaker, whether the issue is with the infotainment system, or issue is the wiring, or if a speaker is going bad, what is causing that breakage of the speaker. So that's where the live diagnostic feature of these green speakers come into picture. We can always ensure the reliability of the speaker by always monitoring the speaker. So here we have the diagnostic which is running on the speaker, which can help us to identify if there's any wear and tear, what is the status of the connection, whether the load is within the limits or something has broken down. So system is always monitoring it, and with the help of all these things, we can always try to reduce the field issues and the rejections by the dealers or the OEMs. Also improves the lifetime of the speakers, because whenever there's an over voltage or over current requirement, the software can curb that. Now, with the help of all these things, we can also design some kind of diagnostic tools also, which can help in alerting the customer whether the issue is with the wiring or issue is with the battery, and always they can be notified upfront if there's an issue. Lastly, what I would say is with the help of these speakers, we are always ensuring the consistency, because now the software is always driving these speakers. They always monitor. So we know if the speakers is underperforming or overperforming, and we can adapt as per that. Second thing, which is the major issue which we have seen in market, is the speakers are always designed for different various climate conditions. For example, if the vehicle is being driven at a minus 30 degree or minus 20 degree, or if it is driven at 60 degree or 70 degree, the speakers are always are same. There is no differentiation in terms of the material and in terms of the composition. So now what we have an offering here is, due to the software which is available on the head unit or the amplifier, we can always compensate for the loss which is due to the temperature. For example, if it is a colder condition and diaphragm is not expanding fully, we can enhance the signal and we can make for that loss in the performance. Similarly, at higher temperature, when the excursion is more, we can always control it to meet the optimum performance. With all these things, what I can offer is we have reduced the weight tremendously, we have reduced the size, and we are performing at the best optimum level. Now, the same speaker, which is a 10 centimeter speaker, it is catering to 16 centimeter. Even the 16 centimeter speaker is reduced in weight. So what I can offer you now as a solution is a same speaker which can go into the commodity, and same speaker which can go into a premium or a branded system, because everything is controlled through the software. Now, what is this software what we are talking about? This software is nothing but the learning what we have taken from last 80-85 years. We have seen how the speakers are performing in the market, what kind of adaptations are required in the speakers. So all those things have been constituted and now applied onto these speakers. So what I can sure is you get a better sound and for the entire lifetime. Yeah. So that is all from our side. We can take up the questions.
Thank you, Rachit. Thank you for keeping it quick and short in the interest of time. And a couple of questions that I would want to direct to you. Just a second. I'm just shortlisting the questions, just screening through the questions here. So, is it, this is from Mr. Mandar Joshi. Is it feasible to achieve Dolby 5.1 surround sound with these speakers, the ones that you showed?
Yes. So answer is yes. Dolby 5.1 or 5.1.2, they are defining the various parameters which these speakers can comply to.
Okay. Okay. Right. And the other question is from Mr. Vinay Mittal. Are rare earth elements being used in the speakers? And if yes, then what alternative do you see from China if there are some import restrictions? And it's a very broad level question.
Valid question. It's the need of an hour. So yes, always the speakers being limited to only ferrite or neodymium in terms of the automotive speakers. Yes, there is a dependency and there is a limitation with respect to the rare earth material availability from China. But I hope the government of India will support us in getting it resolved, and we can all work with that.
Right.
There are
Right.
various other solutions which are currently getting evaluated, but as of now, answer is no for the availability of alternate for this.
Right, right. I hope Mr. Vinay has got his answer. And Rajat, thank you so much. With that, we'll close this presentation session right here. And really
Thank
appreciate
you.
you coming over and giving us your presentation. And finally, we come to the last session, the fireside chat with none other than Mr. Anand Kulkarni, who's again a renowned figure in the automotive industry. He's the Chief Products Officer and the Head of High Voltage Programs and Customer Service at Tata Passenger Electric Mobility. Anand, thank you very much, and sorry to have kept you waiting for a while.
No problems, Mayank. I hope you are hearing me loud and clear.
Absolutely.
Lovely. No, so Mayank, it's always a pleasure. I think this is the fourth time, if I'm not wrong, that you conduct this every year. And thank you for inviting me each year. I'm very glad to be here with you and our other participants today.
Thank you, Anand. It's a pleasure is all ours, and we'll just jump right into the meat of the conversation. And
Lovely.
like we always we sort of talk, and we talk quite often, and you segregate the electric vehicle, the entire vehicle, into different layers. And given the topic of this discussion, which is lightweighting techniques in electric vehicles, so I would want you to adopt maybe the same methodology here as well. And if you can just segregate the entire vehicle into layers, and maybe starting right from the chassis layer, and then we move up. And if we can talk about the different nuances of achieving lightweighting in each of these layers. So how about that?
So Mayank, you've got me cranked up now. But right, I mean, if that's how you would want us to talk about it today, no worries. But I also wanted to take a moment,
Yeah.
Mayank, and also say something which is a little different tone than what we've or what you would want me to talk about
Sure.
in the rest of the conversation. You know, when I received the invitation this time, I was wondering. It's been 4 years we've been talking about it, and the technologies that we discuss each year, they are not necessarily path-breaking technologies.
Mhm.
And we've probably talked about high-strength steels, ultra-high-strength steels, aluminum, magnesium, plastic, carbon composites, all of
Yeah.
these things for quite some time now. And yet, this is a very, very relevant and an important piece of what we do within the industry.
Mhm.
So perhaps it is time for us to start saying that if these technologies have been around for as long as they have, uh, what is that we need to do in order to make sure that there is a higher level of implementation and a higher level of penetration.
Mhm.
So uh, uh, can we pivot the question around not the what but the
Mhm.
how, and
Right.
maybe when we bring the spotlight onto the how, things will start to take a slightly different turn. And of course, that discussion, while it is complementary to what we discuss in the what, I mean, they always go hand in hand, but it just takes on a slightly different vector
Right.
that might help us achieve a little bit of more traction in this space. But I leave that to you, Mayank.
Sure. No, that's a
And
very good suggestion, Anand. And I think how is what we should be focusing today then. And if you can,
no, I'm okay. I'm okay. I mean, you know, I've come here for a nice chat with you and with all our participants. So
right.
I will leave it to you. You've asked
Sure.
me the first opening question, and let
Yeah.
me first begin by responding to that.
Yeah. Sure.
So
Sure.
you've said, explain to us the four layers that I usually explain to you, and then maybe we will take it on
In an,
from
in
there.
an, in an electric vehicle,
Correct.
particularly with respect to an electric vehicle. So if you can just segregate it into the four layers that you usually do, and then if you can address each of those layers. And
Yes.
before that, Anand, if you want to, like you've mentioned, that we should be focusing on the how today, but also if you want to give any specific remark regarding the broader theme, which is today's, we also had a panel discussion before this, and therein, we also had a theme of the trends, the major trends in lightweighting. If you have any quick comment to make on that, and then we can maybe dive into the four layers.
I certainly have a view on that, on the mega trends, and but we will
Sure.
keep that for a later question today.
Sure.
Itself. We'll try and address that.
Okay.
But I do want to start off, Mayank, by saying, when I look at lightweighting, it is inescapable that I look at it as a 2x2 plot.
Mm-hmm.
And on one plot is the cost, and on the other plot, or on the one axis is the cost, and on the other axis is the weight reduction.
Right.
And I can split that up into a 2x2. So you can have low cost or a high cost, and you can have a low weight and a high weight.
Right.
Now, obviously, it is very, very illogical to say that I will pursue something that is high cost and high weight. So let's keep that out, and it leaves us with three. But what is therefore significant to us is we wouldn't want to achieve weight reduction at a significant addition of cost, because that just makes it a technology for the purpose of a technology. It does not really help achieve the kind of goals that we want.
Right.
The best possibility, therefore, that we should all aspire for, and that adds an element of a new filter to all our decision making process, is how do we go low cost and yet achieve low weight.
Right.
And that is where technology has to support us. And if you for a moment leave this thought with you, and we will come back to what we are doing on this or what can be done about it, and then of course, like I said, we should pivot the conversation to the how rather than the what. I think the discussion will start to take a slightly different shape. But just leave that thought, and we'll talk about it. I want to now come to the four layers, particularly in an electric vehicle. And I want to, while I've explained this to you a number of times, but for the benefit of our participants today, I want to say that we look at electric vehicles as an architecture of comprising of four layers. And the bottommost layer is that of the powertrain layer. And the powertrain layer is the power electronics, the propulsion system, and the batteries. The second layer that we should look at is the chassis, although you could argue whether the chassis is the first layer and the propulsion is the second layer, or vice versa. But for the ease of explanation, the second layer is the chassis layer that sort of supports the entire propulsion system and contains everything else within the battery, within the vehicle, that makes the driver connected to the road wheel. The third layer, of course, is the electrical and electronics architecture, which is becoming extremely important in today's time and day, because more and more functionality is getting delivered out of that. There are more sensors, more number of radars, more number of activations than we have ever at any point of time in our automotive profession. And the last layer, of course, is cloud, which is today hosting a large number of applications, a large number of utilities, conveniences, which enable people to achieve what I say the enablement of car as the third space. And that's how this is all lined up, and these are the four layers, Mayank.
Right.
Now, obviously, because we are at this conference today, let's first of all, there is going to be no lightweighting in the last layer, which is a virtual layer, the cloud layer. So let's talk about the other three layers. Now, the broad themes, and this is where I come to those broad themes, is one is material substitution, and that today there is a lot of material investigations that are happening. They've been happening for a long time, but today more so than ever, the cost aspect of a new material being implemented in a mainstreaming, accessible manner is that much more. And I just want to give you a data point. If you look at the past 15 years, the raw material price of aluminum, for example, has hovered around $2,000 plus minus 20%. It's been about $1,500, $1,600 to $2,400, $2,500. But the processing costs of that aluminum have fallen dramatically by almost a factor of 60 or 70%. And as a result of that, when we make components of aluminum today, you find that they are far more accessible, acceptable within a vehicular setup than what was 15 years back. Along with that, there have been certain processes which have improved on the aluminum manufacturing. And also, if you would think of the recycling capabilities and the benefits that it has on the sustainability side, because while it takes more energy to produce aluminum as a raw material, the recycling is much better because of its lower melting point, and therefore it is significantly good. These kind of changes are happening, but therefore you see a lot of aluminum being used in the first two layers of the vehicle, which is so you have motors which have casings made out of aluminum. You have batteries today which are shifting to aluminum. You have suspension components like stub axles or wheel ends. They are shifting to aluminum. Quite a few parts of the suspension are shifting to aluminum. We haven't, there are vehicles which have all panels also in aluminum, but I think they become very expensive because at that point, the cost versus benefit equation does not sort of suit itself. And coming back to the 2x2 matrix that I spoke about earlier, it does not fulfill that area. But that's what is happening in these two layers. When you look at another mega theme that's happening, is that there is consolidation that is happening. There is integration that is happening of multiple components, So you look at the E&D architecture. Today you have domain control units, and the domain control units are basically as the number of electrical actuations functions within a car increased, you got into this situation where there were just too many ECUs. So we said, can we gather them together and make a domain control? And that is the integration part that I'm talking about. But and that then brings you the benefits of being able to use domain controllers as a way to reduce costs, but to go high on functions and therefore add more value to the customers. But at the same time, if you look at what's happening in the integration of the mechanical components, for the electromechanical components, let me say, in an electrical vehicle, you typically had 6 components which were very crucial for propulsion, and they were the motor, the inverter, gearbox, PDU, the the OBC onboard charger, and the DC to DC converter. Now, we had a generation of vehicles where each of these was separate, individual, and then about 3-4 years back, 5 years back, we started having 3-in-1 combo box for the motor and 3-in-1 combo box for the other 3. And today we are already seeing people combine all of these to become 6-in-1s. And there are people who are further talking about 7-in-1s and 9-in-1s. So it is essentially all of this being combining. And what had prevented this earlier? It was the unavailability of the integration capabilities at some of the key supplier ends if some OEs wanted to do that, or within the OEs themselves, or OEs wanting to retain more control on the supply chains and therefore wanting to sort of keep it split even though the benefits were available. But today, I think in the changing business scenario, where we've gone through a shock on semiconductors and we've gone through so many other issues, I think this integration has started to make a lot more sense. As a result of this, we see this coming together. This not only saves cost, it saves weight. Geometric integration becomes easier. It improves reliability and it improves the weight, certainly, because you would expect almost about a 20-25 kilogram weight reduction on account of such integration technologies. So that's another mega theme that we are talking about. And then the third mega trend that we are seeing or we should be following is on how do we make technologies which are rare today or technologies which are slightly on the higher side of premium to become more mainstream. Carbon fibers, for example. I mean, the technology has been known for decades now because we've used that in race cars. But it's always been very, very expensive to bring it down into regular street cars. And over the last decade or so, there's been a significant improvement in the cost of carbon fibers as well because of added manufacturing techniques, added manufacturing capabilities, as well as the scale itself increasing. And therefore, they've now come to a point where not everybody, but at least on the premium vehicles, it is starting to get used. So these are the 3-4 kind of things, Mayank, that I would say are mega trends, and that's what needs to be followed.
Right, right. If I can ask you a follow-up question on the first two layers, Anand, we're talking about the powertrain and the chassis layer here. So if you look at an electric vehicle setup, so there's also talk that if you go more towards a skateboard platform, then also you're making the battery an integral part of the skateboard itself. So does that also call for some amount of weight reduction with that process?
It does, and there are various methodologies to do that. Uh, and skateboard is a very generically used, loosely used term. I mean, at one point of time, skateboards used to be a very flat skateboard under which you mounted a orthogonal battery and you had propulsion units either at either end or at both ends, whichever way you wanted. Because with a electric vehicle, you don't need a propeller shaft to transfer from the front end to the rear end or vice versa. So that's what a skateboard was called. Then it's got, I would say, distorted and marketed as multiple things, and we have this kind of a confusion. But what I would like to say is, so long as you design your vehicle around the battery, you could say that it was a kind of a born EV, pure EV, specific bespoke EV platform. Now, what benefits does it give you? It gives you the benefit of being able to not really fall to the otherwise requirements of the floor and things that you would have. And they are requirements from a crash perspective, or side crashes, front crashes, or from a seating perspective. And more so in the ICE vehicles, they were also about how you challenge the torsional vibrations, torsional stiffness, and the other vibrations that come on account of the powertrain transmissions or the powertrain transmitted vibrations. Now, when you look at all these things, the skateboard does provide with a possibility of simplicity, and therefore, to your specific point, there are executions in other places where the top end of the battery could become the floor.
Right.
Now, this means a lot of pros and cons that have to be considered, including how do you service the car, how do you maintain the car in case of an accident, or how do you repair the car. But these possibilities exist, and it can be used to further drive down the weight of the car.
Right, right. And if we talk about the battery pack itself, Anand, so what are the ways to optimize the weight of the battery pack? And also, there's a huge debate in the industry that, whether to give a bigger battery with higher range, because obviously then you'll also be carrying a dead mass for, for maybe like majority of the use case when that amount of range is not required on a day-to-day basis. So
Yeah, it's a
thoughts on the battery
paradox,
pack
right? It's a
optimization.
paradox
Yeah,
in some ways. No,
absolutely.
so battery designs have evolved, I will say, Mayank. What we were looking at 10 years back and what we are looking at today, there's been a significant upgrade. And let's look at it this way. In any battery, you have a cell cost and you have a non-cell cost. So cell cost is what you would pay for the cells, and everything else that you pay, including the of the amount of material that goes into stitching up the cells together to form modules and things of that sort, or the wiring harnesses, connectors, contactors, the cooling circuits inside is all non-cell, including the trays and the top lid.
Right.
Now, because of the way that batteries are currently laid out, and because of the investigation and formats that are happening, including and this is all a little bit connected. It's not necessarily only at the battery level, but for example, what kind of voltages and what kind of capacities you need, etc. We are seeing that cell to chassis, cell to pack, and these kind of technologies come through, which further reduce the number of components within the battery non-cell part. And that leads to a significant amount of weight reduction, as well as, more importantly, what drives that is the cost reduction again.
Right.
The second thing is, earlier it used to be only steel casings, but today people use aluminum, at least on the larger size batteries, and people also use a hybrid structure to sort of do a good balance between weight as well as in terms of cost. Of
Right.
course, when you do it correctly, you get optimum strength on the sides as well as on the top, and it increases the torsional stiffness of the body by as much as 40-45%, and that is a huge benefit on in terms of ride refinement, etc.
Right.
So there's a lot of work that goes on into this. Earlier also, some of the power electronics would be kept outside of the batteries. Today, there is a tendency to pack that inside the battery because you already have a IP67 or IP69 casing of the battery. Why
Right.
would you therefore want to waste
Metal.
cost and effort in making the other the battery management system or the other BMCM, as we call them, be an outside part with a separate IP67 on them? So you would want to pack that into the batteries. So all of these things are being evaluated.
Right, right. And if we talk about the chassis or the BIW here, we were also discussing this at the start of this event, there's this emerging trend of giga castings. Now
Yes.
you mentioned that, there should be democratization of technologies like in terms of the carbon composites that you mentioned. What's the trend that we are going to see in terms of giga castings when you look at the Indian market, particularly the Indian EV space?
So the giga castings was started initially by Tesla,
Right.
and I think they've been very responsible in sort of bringing that up to the forefront. Today, there are a few Chinese car makers who are also going towards giga castings. Uh, you could also call them mega castings because you don't need to integrate each and everything. You can integrate some few functions, and
Right.
obviously there are benefits in terms of the total number of sheet metal panels that you look at and the joineries, and so it reduces the number of weld spots, it
Right.
increases the integrity. At the same time, you also have to factor two important things.
Mhm.
One is what is the serviceability aspect on those parts. Meaning, if you get a side hit, and if the casting were to get impacted, then you literally have to throw away the casting, and I mean, up to a certain point you can repair it, but you will not maintain the integrity if you did not do that properly. And secondly, you have to look at it from a tooling perspective also,
Okay.
because since you are dealing with molten metal at all times on a large component,
Yeah.
the tool life is not as high as we are used to with some of the other components, and therefore tool replacements are quite higher, I would say.
Okay.
So it works well with low volume,
Low volume.
high tech, premium products, but
Mhm.
bringing it into mass scales where you make hundreds of thousands of cars every month, or hundreds of thousands of cars even every year,
Right.
might need you to reconsider the economics of that scale better. So
Right.
far, I don't think a right balance has been achieved, or we have found that right balance, and therefore, uh, if it is a premium product, then certainly that technology offers. See, because when you have a premium product, you need to invest in manufacturing lines also.
True.
If you do a giga casting, that cost of investment
Understood.
offsets itself because
Yes.
you're talking about a low volume.
Low volume.
But
Yes.
when you're talking about a very high volume product, then that no longer remains the force, and therefore you start looking at it in a completely different manner.
True. True. True.
So that's the state of affair currently with
Hmm.
something like the giga casting. Technology, yes. Matured, yes. Applicability, case to case.
Right, right. As Tata Motors, Anand, I mean, you also are moving up the ladder in terms of premium products, and Avinya is a brand that you're going to be introducing. So, is there any exploration of this particular technology for those kind of products at Tata Motors?
So I wouldn't like to necessarily associate a technology with a product. Technology evaluation should happen in an independent space, because then you then applicate it depending upon what your need is specifically.
Hmm.
So from that perspective, we would have had a look at what it means, but I would not be able to say whether a certain product or other would have a certain technology, because that's speculating a little bit.
Okay, right. And we've talked about, the zonal architectures in the now I'm moving one level up, in the now coming to the A&E architecture of an electric vehicle. And going from very distributed ECUs to more consolidated sort of a zonal architecture. So that obviously is going to reduce weight by consolidation of ECUs. Also, Anand, going more towards high voltage architectures, are we again going to see a lot of weight reduction in terms of the cables that you use, the wiring that you use within the car by moving towards more high voltage architectures?
So high voltage architecture certainly improve the cable weights. There's no doubt on that, because you're basically dealing with a higher level of voltage. But look at it in an overall perspective. You When you go to a higher voltage car, you are basically looking at higher capacity batteries. So yes, you are saving,
Okay.
you are optimizing cable
Right.
lengths, cable weights. But then coming back to that paradox that you spoke about, where a higher amount of battery and therefore I mean we stopped at talking about that. But for example, if you look at what is therefore a point at which the marginal utility of an extra battery ceases to support itself, and that I think is probably around 500 odd kilometers of real life, because beyond that, can you give 800 kilometers? Yes, but you would end up having so much of battery weight and this thing that it might pull out the paradoxical question once again.
True. So what's the way? What's the way of I mean, dealing with copper? I mean, all these wires and cables are primarily copper, and copper is a heavy metal.
Yeah.
So what is the optimization trend that you see in the industry right now towards weight reduction in terms of the wires and the cables?
So there are people who are evaluating with aluminum, but I
Okay.
think you have to be very careful about how you do aluminum cables because of various pros and cons. Again, copper still renders itself to be one of the best when it comes to various properties that we need to have. And going to a high voltage system is one of the ways in which you can reduce the copper content.
Right. And also the last layer, Anand, the cloud layer. Now again, the more functions you're able to put out to the cloud, and you are removing that from the vehicle itself. So you're removing the weight from the vehicle. So again, anything,
Not necessarily,
not
Mayank. Be
necessarily.
careful about where we go there on that, because
Hmm?
what you are putting out in the cloud layer is the ability to interact with an external atmosphere. What you need on the car, you need on the car. And if you need
Okay.
safety, if you need navigation, if you need additional features on the car, then you can't sort of deploy them from outside. That's a little bit of a stretch.
Okay. Right. So all the safety critical functions, they need to be on
Absolutely.
board in the vehicle,
Yeah,
and you
yeah.
can't displace them to the cloud.
Correct. Not certainly not today. I mean, you would first want to achieve maturity
Right.
of everything being done on the vehicle, and then the second enabler to that is to have seamless, contiguous, high powered cloud services everywhere. Otherwise, how do you do that? Otherwise, you're getting into trouble, right?
Right, right, right. I'll also take a couple of questions that we have in the Q&A box, Anand. And we were discussing on aluminium in the previous session, and there's a question which is related to that. And it talks about that there are some inherent limitations to aluminium, like high thermal expansion or lower dent resistance, more fatigue under vibration. So now when you look at moving towards alternative materials, how do you sort of circumnavigate all these things which could arise, and they could not be in sync of what you would want from a durability and a material strength perspective in the BIW?
It is fairly simple. I mean, it's not as complex as we sometimes make out of this. Every component has a unique set of requirements, and unless those requirements are met in full by
Hmm.
whichever material that we use, no
Hmm.
matter how much benefit it gave you, you wouldn't want to go down that road, right? So,
Right,
for example, if there was a component which needed dent resistance, and let's say some material that you were evaluating did not give you that, you would not evaluate it. I mean, it would just fall off the table from an evaluation perspective.
right, right. So you would look at some other material, right?
Yeah, so there is no compulsion that we have to look at a specific technology and
True.
somehow make it happen. We are looking at the ability to substitute a certain opportunity, a certain material with something else, which can be lighter weight, by the way. But unless that core characteristic is achieved, you don't necessarily say, oh yeah, this is weight reduction, then therefore I have to do it. But because then you would have achieved weight reduction, but you would have fallen off on the other attribute.
True, true, true. Could you, Anand, could you just give us a couple of examples maybe that come to your mind of, some innovations that you have done in the Tata EVs from a lightweighting perspective?
So I would certainly say that in the new Harrier.EV, we've used aluminum stub axles, and that's reduced a significant amount of weight while improving the durability and the rigidity of the entire suspension. I would also call out to and that's on account of the inherent nature of electric propulsion. But electric propulsion typically can make do with a lesser amount of NVH material.
Okay.
There is a contrary
Insulation.
view to this. There is a contrary view to this because
Right.
sometimes people say that in order, because electric cars are silent, you need to actually attenuate the tire noise by
Very
filling some
nice.
tire fillers.
Mm-hmm.
But if you actually deal with the stiffness properly, then you are able to reduce significantly on NVH insulation or isolation materials, as well as you are able to go smaller on the rubber mounts and other attachment devices for the propulsion to the chassis.
Okay. But would you be compensating for these materials in say the glasses, the windows and the windshields, maybe you're thickening them?
So, yes, you can. You have impregnated glasses available today, but it all depends on the product and the need. Because many
True.
times, and this is where I come back to not the what, but the how. Because the hardware is available to everybody.
Right.
Who's smarter enough to deploy that to achieve the requirements
Right.
is going to be the winner on that particular day. So just because I have the ability, I wouldn't want to go to an expensive suspension. Because if I have the capability to manage the suspension with standard capabilities and components, why would I throw money at it?
Right. Right. Very
It's
well put.
interesting, and that's the how part of it. So,
Yeah.
and I spoke at the Harrier.EV launch.
Mm-hmm.
ADAS components have been available to everybody, and yet we talk about ADAS today being very intrusive.
Yeah.
Everybody thinks of it as a safety device and everybody wants it, but everybody gets irritated by it because it is very intrusive.
Yeah.
Because ours is a chaotic atmosphere, ours is a chaotic drive situation. So, can we make it into a trusted companion who will take the gauntlet and say that I'm going to make it in a different way? We've tried to do something in the Harrier.EV, and I think that will set the reference for us. But these are the hows that we have to challenge because the whats have already been addressed.
Right. Right. So that's a very frugal engineering approach. It's a core frugal
It's a
engineering
smart
approach.
engineering approach. I
Smart
wouldn't want,
engineering.
there was a time when frugality was a very noble virtue, but I
Hmm.
would say smartness is a better virtue today.
Right, right, right. Absolutely. Great. Just the last note, Anand, I mean, just the global trends, your quick comments on that. What are the key trends, just to sum up this conversation, that you see going forward, in the next 3 to 5 years, in terms of weight reduction in vehicles that we're going to expect in the entire industry?
So consolidation is going to happen not only in propulsions but also in terms of electronics and the E&D architecture. Uh, New materials in terms of carbon fiber, ultra high strength steels, DP 1180 or higher steels coming, which offer 3 times more stiffnesses because there is capacities being set up, there are technologies being brought to the fore, and therefore material substitution will be a big thing, along with no compensation or no compromise on strength. There will be new kind of technologies which come in terms of glasses, glass fibers, plastics, and they will start to become more regular trend in automotive as we go forward because design is about to see an explosion.
Right.
Creativity is going to see an explosion, and some of these technologies which have been waiting in the on the sides are going to become extremely, extremely important. From an electric vehicle perspective, propulsion systems getting integrated, batteries becoming more uniform, and shaving off more cost, making cars more affordable. I think that's the overall trend that I see over the next half a decade. And then there will be another further
innovations.
for further innovation taking place. Yeah.
Right, right. Lovely, lovely. On that optimistic note, Anand, thank you very much. It was a delight talking to you as always. And I
Thank you
hope
very much.
our audience have a lot of takeaways from this conversation.
I hope so. And I loved, like each year, Mayank, it's been a pleasure coming and talking to all of you today also. I love sharing views and taking feedback as well. So please let me know if there are any questions. We'll try and see how we can address them.
Absolutely. Thank you so much for your kind words, Anand. Wish you a great day ahead. And with that, we would like to close the day one of the Autocar Professional Vehicle Lightweighting Conference, powered by Sika and brought to you by Pioneer India Electronics. Tomorrow as well, we have another day lined up of exciting conversations. So we have a panel discussion power packed with some industry leaders joining us to talk about the manufacturing innovations and some of the hurdles and how to navigate them in the area of lightweighting. And then we have a fireside chat lined up with Mr. Amit Jain, who is the group CTO of Uno Minda. So tomorrow, do log in same time, 3 o'clock in the afternoon, and get ready to be engaged in another session of exciting conversations. See you tomorrow. Thank you so much.